This is a supplementary video to the previous one, which was, I forgot what video that was. I know you can't see it right now, but I'm looking at the PowerPoint. That was video. The one that I just completed was video 4, example 3 of a trig identity. And I mentioned in that video that there's a cleaner way to organize your work. So I just wanted to show you that way and just right now. I'm going to do this by hand, but let me show you how I think students should organize proofs of trig identities. So if you're watching this and you're currently one of my students, this is how I want your work to look. Okay, so start with one side and then perform whatever action you're going to perform. The first move that we performed on this was using two quotient identities. And in a sense, I've already boxed myself into a corner. So I'm going to clear this out a little bit and start over. We're going to start with cotangent of x plus tangent of x. And let's turn that into the two quotient identities, which are cosine of x over sine of x. And then for tangent, sine of x over cosine of x. Now, you may be wondering, hey, in the video it was thetas and here it's x's. Why did you make that change? Well, number one, the actual variable doesn't matter. It's the structure of the thing that matters. And number two, I couldn't type a theta easily when I typed the actual instructions on this one. But when you pull off a move, what I would like for you to do is go to the right and cite what you did. In this case, I did quotient identities. Then I would recommend progressing vertically. So for example, the next move that we did is we multiplied both sides of each fraction by the right thing to get a common denominator. So in this case, we would multiply the first fraction by cosine x over cosine x. Wait a minute, I'm restating everything that we did in the previous video. I'm not meaning to do that right now. All I'm meaning to do right now is to show you what I think is a good way to organize your work that makes it easy for me or anyone else to follow. Now, what I just did here was not a trigonometry move. It was an algebra move. If you want to go over here and cite algebra, that's fine. It's not a bad idea to cite what happened on each move that you did. And then on the next move, we simply put everything together. Come on, go away. And we got sine of x, cosine of x, over cosine squared of x, plus sine squared of x. And again, if you were going to do a citation here of the move that you did, you would just say algebra because we didn't do trigonometry. And then on the next move, we turn the top into 1. And the reason we did that was a Pythagorean identity. So we would go to the side and say Pythagorean identity. So this way, as you're doing your verifications, your proofs, if you will, I can see the moves that you did and why you did them. Now I'm going to do something a little bit different than I did before. On the previous video, we went to the right side and turned it into this also, but I'm going to reverse engineer the algebra that gets us there. I'm going to split this into 1 over cosine times 1 over sine. And again, that's not a trigonometry move, that's an algebra move. And then I'll finish it off by saying secant of x times cosecant of x, and both of those are reciprocal identities. So when you are verifying your identities, for me or whoever your professor might be, this is almost always a perfectly acceptable way of organizing your work. Start with the one side of the expression, put it equal to something, cite the move that you did, and then move vertically. And as you make changes, cite the reasons that you did. Just keep in mind that sometimes the reason is algebra, sometimes the reason is trigonometry. For my students, if it's algebra, you can just say algebra. But if you do a trigonometric move using an identity, you should cite what identity that you used. This is the format that I will expect my students to do their homework in.